Hello, welcome to my channel again. Okay, last time we talked about the concept of chemistry and what chemistry is all about. We try as much as possible to break it down in such a way that even non-science students can relate with it, right? Today we want to talk about the concept of atom, element in relation to element. We want to talk about the proton, neutron, and electron. We want to talk about rows and column in chemistry, how they came about these rows and column, how they classify element into rows and columns. So let's dig in right away. Okay, so we are going to start with the concept of atom. And I will start with this analogy. When you see a house, you notice that as big as that house is, there is something, there are blocks that made up the house, okay? A house is a compilation of blocks, right? Blocks, building blocks, right? They came together to form a structure, okay? Those building blocks, right, can be likened to atom. Okay, so they make up the structure, but they contain the properties of that structure. When you see a house, you see a strong house, right? But no house is as strong as the quality of blocks that made up the building. Okay, so when you look at the house, you see blocks coming together to form that house. If you see a house standing, that means you see blocks standing. Those blocks are likened to atom. They are what made up the building. Okay, so and they contain the properties of that building. The house is strong, then the block also is strong. I don't know if you understand me now. Okay, the house is well is solidified. That means the blocks are also solidified. So these are just a simple analogy to describe what atom is in an element. Atom is that small unit, right? But they contain the properties of that element. Okay, so let's look at it in another way. And that will lead me to the proton, neutron, electron. When you see an orbit, right, it has a nucleus, and you have probably what is rotating around the orbit. Okay, so in that orbit, there's what we call nucleus, right? It is that nucleus that contains the proton and the neutron, right? But what you see rotating around it is what we call the electron. Let me simplify that. Okay, proton are considered positive. Proton are considered positive, okay? Electron are negative, while neutron are basically neutral, just as the name implied. Okay, so what does this thing, what do they do? Okay, so proton are considered to be let me use the word identity card. When you see a proton, you can predict the kind of element that we're talking about. The number of positive, let me use the quote and unquote now, let me use the word positive energy that you find in a particular element is like the identity card of that element. Okay? The neutron are considered the peacekeepers. They don't want wahala, they don't want trouble, they don't want proton to start repelling each other. So for an element, the neutron is like the mass, is what is keeping peace, okay, with the element. Why the electron rather is like the social butterfly. Okay, social butterfly is they can form relationship with other atom. They can join and combine. They can bond with other atom. So we have proton, like the identity card. You know what identity card does. We have neutron, okay, the peacekeeper, and we have electron, the social butterfly. Okay, and these are what help in grouping this element into rows and column, and that will lead me to the third point: rows and column. Okay, so when you look at when you have the one that goes like this straight line, you consider that the row. Okay, the one that comes like this, consider that the column. Do you understand me? So you have group, you have elements are into this group. So you have the group 1, you have group 2, you have group 3, 4, 5, 6, 7. Okay, down like this. Each the element in a particular column that comes down like this, you consider as group. Okay, that's group 1 element. So we have element like hydrogen, lithium, sodium in a particular group, right? Then across like this, you have element like hydrogen, helium in the same period. Okay, so why are they like that? Why do you have hydrogen in one group and we have helium in another group? Why can't they just all be in the same group? Remember I talked about identity card. Now when you looked at the number of proton in a particular element, it gives you the identity card. And you look at the number of proton in a particular element, it shows you the identity card. They have what they have in common, right? So let's look at another thing to consider is the electron. Okay, so let's look at helium and hydrogen. They belong to the same group, right? So what do they have in common? They have one electron in the first shell. So you look at them, you see them with one electron in the first shell. You can definitely belong to the group 1, to period 1, right? You have lithium and neon. Yes, lithium and neon in group 2, and you wonder why? Because they have 2 electrons, okay, and their shells. Then you have helium and neon, and we ask the question, why are they in this group? Why? Because they both have outer space that is filled, right? They are filled already. So to break this down, atom is essential to every element. They are the building they are like the building blocks for this element. We contain all the properties of this element. Okay, so I hope I've been able to help someone to quickly identify these things so that it doesn't become a burden to such a person. Thank you so much. See you in the next class.